All right, let's go. I know I've been talking for quite a while, so I'll try to make this short and sweet and just jump into the mass spec. But before we do that, you obviously need to look at the other spectra to get an idea of what's there. So first thing we always look at is the IR spectra. IR is telling me what? What function group?
I think it's alcohol.
It is an alcohol. You can't see because it's not on the board. Thank you for...
How would you tell that different from a secondary amide? Because it looks kind of similar.
This one?
No, just like in general.
From a...
Because you know that that one, is it primary amide? The secondary amide.
So a secondary amide with the little, like, you would expect a carbonyl. And if it was a secondary amine, that peak would be way smaller.
Oh, yeah, it's like this.
Yeah.
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 Okay, yeah.
All right, so my first bit of information is that I'm dealing with an alcohol. That there tells me OH. I'm just going to write it to the achieved level just because the main thing I want to talk about today is mass spec, but you guys know what the achieved merit and excellence requirements for these things are, right?
Yeah.
So an achieved level student is just identifying things on there. Merit level students tying it all together, seeing all the different components to be able to figure out what function group it is. Excellence level student is able to show me some process elimination. Cool. All right, second bit of information then is my CMMR. So with my CMMR, we are just doing Sesame Street counting. And I see that there's 2 peaks. So what that tells me is that there's 2 carbon environments. The other thing that I want to see here is knowledge of, grabbing my resource sheet, is tying in the functional groups to back up each other. So like, for example, when I'm looking at this here, I can see that I have 2 peaks. I know I have an alcohol, and I would just want to verify my alcohol. So I see that if I have a carbon attached to an alcohol, on the CMMR, I should see around 50 to 65, and there, it's a little bit higher than 60. This is why I'm saying that you use the IR as your main reference point. The CMMR is going to probably be a little bit off potentially, but that peak there is my carbon with the OH. So remember, you're starting to use each other to back it up. I'm not obviously writing this up to the merit or excellence level. I'm just trying to quickly fly through it so we can get to the mass spec. We'll have a good amount of time later to do full justifications. All right. So for the mass spec, let me talk about what you need to do for the achieved. For the achieved, I just need you to tell me bare bone basics. Which one's the base peak? Which one's the molecular ion? So molecular ion, I've actually labeled it because it's super tiny. It's very hard to see it. And so that is an example of me giving it to you. You should still identify it as the molecular ion, though, just to show that you know what it means. So you'd say molecular ion is equal to 60 mass to charge ratio. The other thing I need you to do at the achieved level is label the base peak. So the base peak is at 45. So remember that base peak is talking about the most common fragment that we see. Are we okay with that so far? All right. Let's start taking some guesses of what molecule I have here. So I have 2 bits of information. I know I have an alcohol, and I know I have 2 carbon environments. So if I'm assuming the bare bones stuff, I would say, oh, I must have at least ethanol, because that fits the components of it. Let's now do the mass of ethanol to double check if that is correct. So when it comes to the mass, you are using the atomic masses on the periodic table. So that's why you're given a periodic table for this assessment. I see that I have carbon, which is 12. I see I have hydrogen, which is 1. And the last thing is the the oxygen, which is 16.
Oh, yeah.
So we substitute in the numbers for how many carbons, etc. So I have 2 times 12, that's my carbon, plus my hydrogens, I have 6 times 1, plus my oxygen, which is 16. Are we okay with that so far? So if I did the math there, I have 12 times 2 plus 6 times 1 plus 16. So total, I would have 46. Do you see how that mass doesn't match this mass? So what does that tell me? It's wrong, but there must be some symmetry in the molecule. Because we see that there's 2 carbon environments for the CMMR, but the mass spec is 60.
Oh, so it has to equal 60.
It has to equal 60. Whatever my mass is, it needs to equal 60. So it's not this formula, is what that's telling me.
So it could be like
It could be. So like for the easiest way I find to try to figure out something is I always assume the N bit. So I always go, we have alcohol as my chunk, and then I don't know how many I have with my R group.
Yeah.
So if I did the math behind here, I would have 12 plus 3 plus 16. So this component here is 31. And in fact, I give you a shortcut here. So my little trick to help me quickly figure out how many I have is I add the number 14 until I'm 1 away from the answer. Because each time I add 14, I'm adding a CH2 inside. So if I add 114, I am at 45, which we know is not right. If I add another 14, I'm at 59, which is 1 away, and then I end it with the 1 hydrogen. I'm at 60 now. So what this tells me is that this molecule has 1, 2, 3 carbons. Do you see what I'm saying? So the 14 I got from here, because if I have a carbon with 2 hydrogens, that's 14. So if I add 14 each time, it tells me then how many carbons I have. So I'm assuming I have the N carbon, and that's the formula that I have, and the mass, which is 31. I add 14 to assume I now have 2 carbons. It's still too small. Add another 14, I'm now at 59. Add 1 more for the hydrogen at the very end of the molecule, 60, and it matches the molecular ion. That's how I figured that out.
I think we're just really counting that on our problem. You know what I mean? It doesn't have to be.
Yeah? Yes, because you need to figure out what the molecule is. So if you want to get merit or excellence, I need to know what the molecule is. So what I have is CH3, CH3, and then an OH. That's my molecule. If it's all the parameters, I'm going to put a little positive sign because that then tells me molecular ion, because remember it's supposed to be charged. Cool? All right, so let's see, does it meet all the parameters of the other 2 spectra, because they need to back each other up. So I have the alcohol, which is what I saw in the IR. Do I have 2 carbon environments?
Yeah.
Yes, because of the symmetry. So you see what I'm saying? The carbon environments are useful to help you get a head start, but it doesn't always reflect the number of carbons that are there.
Yeah.
So that's my answer for this, looking at all three spectra. So for the merit, I need to see that you know what the molecule is. The other thing is I need you to tell me a fragment. So any fragment will do. I need you to tell me an example of one. When you are working, you can work both from the peak or from what is lost from the peak. So I find it's useful sometimes to do 60 minus 45, because then that tells me what I've lost. So that tells me if I go from 60 to 45, I have lost 15. And losing 15 is a really good marker for me, because what's 15 usually? CH3. And in fact, I give you a list of common fragments. You can see CH3 is one of them. So this 45 peak, what has happened is I've lost one of the methyls on the end. And so 45 now is CH3, and that's a charged component. And if I did the math behind there, it would equal 45. So 12 and 12, 24, 3, 4, 5 hydrogen, so I'm adding 5 to that, and then 16 from the oxygen, that equals 45. So that tells me then the base peak fragment.
So like with a peak, you have to show like what
The fragment, yeah. You can do any one on there. So if you want, you can do 15 and tell me that 15 is CH3 plus. So for the merit, I need to see that you know what it is, molecular-wise, and I need you to identify at least one fragment off of the mass spec. If you're worried that you might get it wrong, identify 2. Or identify 3. So that's what I need for the merit. For the excellence, I need you to show understanding of what has been lost. So for this one here, what have I lost? I've lost CH3, and I put a dot because that reference that's the uncharged fragment. So this is the 15, and that is my 45. Because it should add up to 60. If I was looking at this one here, what did I lose? I lost that CHOH1. So you see how this is the fragment, but I lost the, sorry, it's the same fragment pattern, but the other one's gotten the charge. So for excellence, I need to see that you understand how it's breaking apart. The other thing for excellence is process of elimination. So you could use that as a means to help justify what fragment you have. So for example, I could try to rule out CH3, CH2, CH2OH. So this is what it's not.
Yeah.
And I know that for several different reasons.
So it's like how we calculated that one mass?
Yeah, so this one here, the way I can figure out how it's not the propan 1-ol, the IR doesn't help me, CMR does help me. So I can say it's not this one here because this one has 3 peaks and that only has 2 peaks. So there's multiple ways you can have one isomer and justify it in multiple ways. So it's not this because it has 2 peaks and this is 3. The other way you can justify it is based on the fragment patterns. So when I look at these 2 molecules here, this one has a unique fragment that you can get that this other one can't get. So in this one here, I can have, 12 plus 2 plus 1 plus 16. That one can get me a 31. And this one can get me 15 plus 14, a 29. Whereas when I cut this guy up, I can't get that combination. Because when I cut it here, that's a different combination of atoms that don't add up to the same number. So if I had propane 1-all, I would expect big peaks at 29 and 31. But I don't see that. So that's the other thing about mass spec. It can help you rule out what other isomers are there because the fragment patterns don't look right. And that's why I'm saying when you're actually doing this practically in the lab, these are specific fingerprints to each molecule. So if you were actually working in the lab, you would take this fingerprint, you'd look against the library, and it would tell you this is the molecule you have. But because you don't have the library, you have to use the IR and the CMMR. Does that make sense?
I need to eat more glue.
Huh?
I need to eat more glue.
You need to eat more glue? You zoned out. That's okay, I've recorded it. All right, so like I said, for the achieved, it's really, really easy. You're just telling me what you see. For merit is where the big jump is because you have to figure out what the molecule is. And then for excellence, it's not too bad. You just have to add in that extra layer to tell me what it's not and why. Cool? All right, that's it for me. I'll let you guys have the rest of the period as tutorial. I'll pass up the homework. You guys can choose to work on chemistry or another subject. I'm not too fussed. And don't worry, I will scan this so you guys have an example. And obviously, this is day 1 of mass spec. We're going to do a couple of days on it. There's more I need to teach you about it.
So do you have another workmat or not?
I have a worksheet that doesn't have a full question like this. I just wanted to introduce it so you can see the full big picture. I think my plan is to do halogens in our next lesson, and then more practice on fragmentation. Huh? Another bingo? No, you guys gotta do some work.